Okay, so what I'm going to do is I'm going to work through problem 3.24, which is on page 119 in your textbook. This is actually a practice in balancing equations. So I'm going to go through these step by step, and you'll be able to see how I recommend that you balance these. It's pretty much look at what you've got and add coefficients where needed so that you can actually balance the equation. So in the first one, we've got carbon plus oxygen gives us carbon monoxide. So I do a tally on each side, and I have my reactants on one side, and then the products on the other, and then my reactants are carbon and oxygen. On the reactant side, I've got one carbon, and on the product side, I have one carbon. On the oxygen side, the reactant side, I have two oxygen atoms, and on the product side, I only have one oxygen atom. So the first thing I need to balance is carbon. That's how I recommend doing it, but you'll see carbon is already balanced, so we leave it alone. Then we have to balance our oxygen. So if we look on the right-hand side, we'll see that we only have one oxygen, and on the left-hand side, or the reactant side, we have two oxygens. So the simplest way to change that is to put a coefficient in front. The only thing you can add is whole number coefficients. So that's going to change that from being 1 to 2. But notice what it also did is it changed our carbons from being 1 to also being 2. So in this case, we have to come back and clean it up by putting a coefficient of 2 in front of our carbon so that we wind up with 2 on each side, and then it's balanced. So with the B problem, we have carbon monoxide plus oxygen gives us carbon dioxide. And so in this case, I'm going to write it down again with my reactant side and my products. We'll see on the reactant side, we have carbon and oxygen. And on the product side, we also have carbon and oxygen. We have 1 and 1 for carbon. And then with oxygen, we have 3 and 2. Well, looking at this, I'm going to notice that first off, I can't multiply the 2 by anything and get an odd number. So on my left-hand side, my reactant side, I need to start looking at what can I do to give me an even number of oxygen. Well, the simplest thing to get an even number of oxygen is to multiply the coefficient of 2 on that. Now the 2 multiplies the carbon and the oxygen. It does not multiply the oxygen from the other, from the oxygen elemental. And so what that does, it gives us a total of 4 oxygens on the left-hand side. To balance that on the right-hand side, we would need to put a coefficient of 2, which makes sense because we also changed our carbon to 2 when we put the coefficient on the left. And now we have the carbon with 2 there. 2 times 2 oxygens will give us 4 oxygens. So that one would be balanced like it is. Let me erase out this little part here. Okay, let's continue on and look at letter C. We have hydrogen plus bromine gives us hydrogen bromide. On the reactant side, we have, of course, our hydrogen and our bromine. And we have 2 on the reactant side of the hydrogen and 2 also of the bromine. And on the product side, we have 1 of hydrogen and 1 of bromine. This is a very simple equation to balance because if we only put a coefficient of 2, that would change it to having 2 of each. I forgot to put my little table there, reactants and products. So that one's balanced just like that. Potassium plus water. This is a very violent reaction. It gives off a lot of heat, catches on fire. The hydrogen gas actually ignites in this reaction. So we've got potassium metal. So that's the reactant. We also have hydrogen and we have oxygen, all on the reactant side. So potassium, we have 1. Hydrogen, we have 2. Oxygen, we have 1. On the product side, we have 1 potassium. We have 1 oxygen, and we have 3 hydrogens. Well, just like in that previous problem with the carbon monoxide and the oxygen making carbon dioxide, we've got a disparity because we've got 2 substances in our products that contain hydrogen. So we want to make that have a even number because you can't multiply the 2 hydrogens on the left by anything and get an odd number. So to make this have an even number, we would just go back and put a 2 there, which now gives me 2 hydrogens plus another 2 hydrogens, which will give us a total of 4 on the product side. But when I put the coefficient of 2 there, I also changed my potassium to 2. So I need to put a 2 in front of my potassium on the reactant side also. Now my potassium is balanced. My hydrogen is not balanced. Why is my hydrogen not balanced? Well, because I have too many. So I put 2 there. Now I've got 4 hydrogens. You know what we forgot? When we put the 2 in front of potassium hydroxide, it also gave us 2 oxygens. But now the 2 in front of the water also gives us 2 oxygens, so that's balanced just like that. It always works out. It's the weirdest thing. It's like riding on a seesaw in my head. Magnesium and oxygen, very easy one to balance. I hope you can get this one without thinking too much about it. Magnesium on the reactant side, we have 1. On the product side, we have 1. Oxygen on the reactant side, we have 2. On the product side, we have 1. Very easily put a 2 in front of the magnesium oxide, and then that changes their oxygen to 2. It also changes the magnesium to 2, but we put a 2 back on the magnesium side, the reactant side. Ozone decomposes and becomes oxygen. We get the disparity again of a odd number and an even number. You can't multiply an odd number and get an even, except we can't multiply an even number and get an odd number at all. So we know that we've got to have an even number of both. Easiest way to get an even number on the left-hand side with the ozone is to put a 2 in front of it, which changes that number to 6. On the other side, we've got oxygen. We have 2. If we just simply change that to a coefficient of 3, we'll get 6 oxygens also. I put a 3 here. I meant to put 6 there. Oh, went too many. Now we have peroxide, hydrogen peroxide, H2O2, decomposes into water and oxygen. We'll have hydrogen and we have oxygen. We have 2 on the reactant side of each. On the product side, we have 3 oxygens and we have 2 hydrogens. As again, when we have an even number on the left side and an odd number on the right side, we need to make that right side balance with an odd number if possible. And then that should give us what we need. So I'm going to take my water and I'm going to multiply that by 2, a coefficient of 2, which now gives me a total of 4 oxygens on the product side and 4 hydrogens on the product side. We'll look back at the reactant side. We'll see that hydrogen is not balanced. We need a coefficient of 2. I wrote the 2 there, meant to write the 4 there. And that also multiplies by the oxygen, so it works out nicely. And you'll wind up with a balanced equation. So that went changed to 4. Nitrogen and hydrogen going together to make ammonia gas. We have nitrogen and hydrogen. Nitrogen we have 2, hydrogen we have 2. On the right hand side we have 1 nitrogen and we have 3 hydrogens. As I tend to say many times, balance your oxygens and hydrogens last. On the left hand side, we'll balance our nitrogen with our reactant, with our product. We'll put a 2 there. That changes us 2 nitrogens. It also changes us to 6 hydrogens. And it kind of solves the problem for us, because then we know that we would need a 3 here, and that would give us 6 hydrogens. That's balanced. Here we have zinc and silver chloride. This is a single replacement reaction. The zinc takes the place of the silver. So we'll write all of these out. We have zinc. I did not mean to write that as a capital N. Zinc, we have silver, and we have chlorine. And on the left side, we have 1 of each. On the product side, we'll have 1 of each of the metals, but 2 of the chlorides. Immediately, we should see that we need to multiply this side by 2, which gives us 2 chlorides, but it also gives us 2 silvers. So to balance the silver, we would just put a coefficient of 2 there. We wind up with 2, and that one's balanced. Here we have sulfur in a sulfur S8 complex. It's an unusual compound, sulfur. You can have different colors. S8, I think, is yellow sulfur. I don't know. It's one of those. So we've got to balance it out. On the left side, we've got sulfur, which has 8. We also have oxygen. We have 2. On the right-hand side, we have sulfur of 1 and oxygen of 2. Easy one to balance out, because all we've got to do is give us a 8 in front of the sulfur dioxide, excuse me. And then to balance the oxygens, now we have 16 oxygens, which is quite a lot. But we'll just put a coefficient of 8 in front of the oxygen to make it balance out. I put the coefficient here again. I keep making that mistake when I'm explaining it. My brain just outthinks my mouth. Here we have a acid-base neutralization reaction. Sodium hydroxide is a base, and that combines with sulfuric acid to give us sodium sulfate and water. Sodium sulfate is a salt. So we have sodium, we have oxygen, we have hydrogen, we also have sulfur in this reaction. So on the reactant side of sodium, we have 5 oxygens, we have 3 hydrogens, and we have 1 sulfur. On the product side, we have 2 sodiums, we have 1 sulfur, we have 4 plus 1 is 5 oxygens, and then we also have 2 hydrogens, just like such. All right. It's always said if you'll save your oxygens and hydrogens in your waters till last, water, then hydrogen, then oxygen, or some semblance of those. Save those and balance those last. Things work out easiest. So I balanced my sodium first. I changed that to a 2 by putting a coefficient in front of it now. What that changed is now I have 2 oxygens plus another 4 oxygens, which will give us now no longer 5 oxygens, but instead 6. We would also have 2 hydrogens plus another 2 hydrogens, which would give us no longer 3 hydrogens, but 4 hydrogens, and the number of sulfur would stay the same. So we'd go to the right-hand side, and we would see we have Na2 is correct, SO4. All right, so we need to balance it on the other side, go in the other direction. And we'll see we have 4 hydrogens and 6 oxygens. So we have a deficit of 2 hydrogens. Well, easiest way to make up those hydrogens is to multiply that by a coefficient of 2. That gives us now 4 hydrogens, so our hydrogen is balanced. 2 also multiplies by the oxygen in the water, and now we have 2 plus 4, which gives us 6 oxygens, and so it's balanced. Now, if I had started out this equation and tried to balance my oxygens or my hydrogens first, it would have taken me forever, and I would have had a huge headache when I was done, and I would have said, I hate chemistry and everybody who practices it. Here we have chlorine, we have sodium and iodide. This is chlorine gas plus sodium iodide, which is a salt, gives us sodium chloride and iodine, which is metallic, well, semi-metallic, the elemental form of iodine. On the left, we have chlorine, we have 2 of those. We have 1 sodium and we have 1 iodide. On the product side, we wind up with 1 chloride, 1 sodium, and we wind up with 2 iodides, 2 iodine atoms. In this case, chlorine, very easily, we're going to put a 2 in front of that. That gives us a total of 2 chlorides, so that's balanced. That also changed my number of sodiums to 2, so I need to balance that by putting a 2 over here. We'll wind up with a 2 there, but that also multiplied by my iodide, so that cancels that, and we get 2, and now it's balanced. Well, I actually intended that video to be all in one take, but for some reason it stopped recording when I got to the last set of problems here. So let's look at this one. Here we have potassium hydroxide with phosphoric acid, gives us potassium phosphate and water. This is an acid-base neutralization reaction. We have a base and an acid added together, which produces a salt and water. It's very similar to K here with sodium hydroxide and sulfuric acid. Gives us sodium sulfate and water. All right, so first thing we'll do is let's tally up what we've got. We've got potassium, we've got oxygen, we've got hydrogen, and we have phosphorus. So on the reactant side, we have 1 potassium, we have 5 oxygens, we have 4 hydrogens, and we have 1 phosphorus. On the product side, we have 3 potassiums, and we have 1 phosphorus. We have 4 oxygens plus another one, so that's 5 oxygens. And then we have only 2 hydrogens. Alright, so what we want to do here is get to balancing. First thing we can easily balance is go ahead and balance the potassium. We have 1 and 3, so we would balance that by putting a coefficient of 3 in front of the potassium, which now makes us have 3 potassiums on the reactant side and 3 on the product side. So potassium is now balanced. However, that did change the number of oxygens to 3 plus 4, which is 7. And it changed the number of hydrogens to 3 plus 3, which is 6. All right, I always say save oxygen for last. That's my best advice for you at all times. Hydrogen next to last, oxygen last. All right, so look at phosphorus. We'll see phosphorus is still balanced with 1 on each side. So let's look at the hydrogens next. We see we have 6 and then 2. And the easy way to get 2 up to 6 is to put a coefficient of 3 in front of the water. Now we have 6 hydrogens. And let's see what happened to the oxygens when we did that. We have 4 oxygens from the phosphate, and then we have 3 from the water, and that would be a total of 7. And guess what? Now it is balanced. Yay! So let's look at the last one here. This is methane gas with bromine, which gives us carbon tetrabromide and hydrogen bromide. Let's go ahead and write down our elements. We have carbon, we have hydrogen, and we have bromine. On the reactant side, we have 1 carbon, we have 4 hydrogens, we have 2 bromines. On the product side, we have 1 carbon, we have 4 bromines, and we have, oh, no, we don't have 4. We have 5 bromines, and we have just 1 hydrogen. So when we're looking at it and we see that we have a even number and an odd number, we need to bring that even up to make it balance out. We could balance the bromine first, but I foresee that we're going to have an issue if we do that, because when we start adding coefficients in front of bromine, we have 4 and then just 1. If we put a 2 there, which would give us an even number, because even numbers, 2 has to be multiplied by even number to get an even number. That would give us 6 over here on the product side. But it changes the number of hydrogens to 2. So if we balance that one first, we're going to take an intermediate step here and look at it and realize, oh, wait a minute. All right, we can balance that because now we would have a 3 in front of the bromine, which would give us 6. So bromine would be balanced. However, our hydrogens are not balanced. So the easiest way to do that is go ahead and double the number in front of the hydrogens. I'll take that up to 4, which gives us 4 hydrogens. So hydrogen is now balanced, but that changed my number of bromines. And so we now have 4 plus 4, which is 8 bromines, which can easily be rectified by changing this coefficient to a 4. Now, looking at that, working it through one step at a time like I did, sometimes you have to do that. Sometimes you have to go back and you have to change your coefficients to make it all fit. All right, so that should be the rest of these.